Welcome to the deep dive. Have you ever thought about a bustling city? One that's constantly changing, buildings go up, they come down, but somehow the mail, it just gets delivered perfectly every single time. It sounds like chaos, right? But there's this invisible system making it all click. Today we're doing a deep dive into pretty much the same idea, but, in the software world. Kubernetes Service Discovery and DNS. Our mission for you today is really to demystify how applications actually, well, find each other and talk seamlessly inside a Kubernetes cluster. Even when their actual locations are shifting all the time, we're pulling insights from sources like Kubernetes Service Discovery and DNS Explained, going to give you that shortcut to really getting this fundamental concept. So if you've ever scratched your head wondering how these super dynamic systems stay connected, stable, this deep dive is definitely for you. Get ready for maybe a few aha moments. All right, let's just kick things off then. At its core, what are we talking about with service discovery and DNS in Kubernetes, and why should we care right from the start?
Right. So, at its most basic, service discovery is just the process that lets applications, could be other pods in your cluster, could even be clients outside the cluster find, and talk to services without needing to know their specific IP addresses, which, as you mentioned, change. And DNS, the domain name system, is absolutely key to this. It's what provides those stable, human-readable names for your services and pods, names that then get resolved to whatever the current IP address happens to be.
Okay, so DNS gives it a name. Service discovery is the act of finding it, using that name.
Pretty much.
Yeah.
Yeah, you can really think of service discovery and DNS together as a kind of smartphone book for your Kubernetes cluster. Think about it like this. Pods and services are people, right? And their phone numbers, their IP addresses, well, they're changing all the time because pods get restarted, they scale up or down, they move nodes. DNS gives them a stable name, something like my-service.default.svc.cluster.local. So other pods can just call that name, and they don't need a separate system to constantly track the changing numbers. Service discovery is that whole mechanism, making sure everyone can find each other easily.
That phone book analogy really clicks. So it sounds like if I'm building something, I just use the name, and Kubernetes handles the finding part.
Exactly. Kubernetes does the heavy lifting. It runs its own built-in DNS service, usually core DNS these days, right inside the cluster. And this DNS service is constantly keeping track, mapping those stable service names and sometimes pod names to their current IPs.
And it updates automatically.
That's the crucial part. Core DNS automatically updates its records whenever services or pods are created, deleted, scaled, moved, whatever. This dynamic updating is what ensures reliable connections, no matter how much churn is happening in your cluster. Plus, it works across different logical boundaries, like namespaces or even different nodes in the cluster, which is, absolutely essential for anything complex or distributed.
Okay, give me an example. How would that actually look in practice?
Sure. Let's say you have a web front-end pod. It needs to talk to a back-end API service. The front-end doesn't care where the back-end pods are running or what their IPs are. It just uses the back-end's DNS name, like backend-api.production.svc.cluster.local. Or maybe a database pod needs to be found by several application pods, even if they're in totally different namespaces. They just use the database service name. Even things like external monitoring tools can often use these stable DNS names to find and scrape metrics from your services.
Okay, that immediately sounds like a huge simplification for me as a developer. It's not just about connections not breaking. It feels more fundamental. Like it's decoupling my application's logic from where it physically runs. I can just focus on what service I need to talk to, not where it is this second. That feels like a massive step up.
You've hit on a key point.
Yeah.
Which brings us to the next logical question.
Yeah.
Why is this system even necessary? Why can't we just, use IP addresses like maybe we did in older, more static setups?
Yeah, I mean, I remember the days of managing IP lists and config files.
Yeah.
Not fun. So I have an idea why, but spell it out for us. What's so different about Kubernetes that demands this?
It really boils down to the inherent dynamism of Kubernetes. Pods are designed to be ephemeral. They get created, destroyed, rescheduled onto different machines constantly, for scaling, for updates, for hardware failures, and almost every time a pod restarts or moves, boom, it gets a new IP address. So if your applications were trying to hard code those IPs, or even reading them from some config file that you have to manually update, well, your connections would break constantly. You'd have this incredibly dynamic, self-healing platform, but your application communication would be super brittle. It kind of defeats the purpose.
Okay, so avoiding brittleness is job one. What other big problems does this whole DNS and service discovery system solve?
Well, beyond the absolute critical need for stable addressing, just having those consistent names, it leads directly to simplified communication. Developers can use easy, human-readable names like user service or CartDB instead of trying to remember or manage 10.42.17.3. This makes configuration way easier and less prone to fat finger errors,
Yeah. Definitely less error prone.
Right. And then there's load balancing. Service discovery is tightly integrated with Kubernetes services. When you use a service name, DNS usually points you to the service's virtual IP, and the service itself intelligently distributes the traffic across all the healthy pods backing it. So you get load balancing and improved reliability kind of baked in.
Ah, okay. So the service object does the load balancing, and DNS just helps you find the service.
Exactly. They work together. It also enables cross-namespace and even cross-cluster communication in some setups, which is vital for larger, more complex, maybe multi-tenant applications. And the final piece, which we touched on, is the automation. DNS updates happen automatically. No human needs to go edit a file when a pod restarts. The system just handles it, ensuring things stay connected.
Wow, okay. So it sounds like Kubernetes basically abstracts away a whole class of networking headaches that used to keep people up at night. No more frantic debugging at 3 a.m. because the service IP changed after a restart. That's huge.
That's precisely the goal. Yeah, if you tried to build a dynamic system on Kubernetes without using its service discovery and DNS, honestly, it would be a nightmare. You'd be back to hard-coding IPs or maybe using external service registries that add complexity and points of failure. Scaling would be incredibly painful. Connections would drop all the time. It just wouldn't work well in a truly dynamic environment.
Let's make it concrete. Use that e-commerce example again. How does it play out?
Okay, perfect. So microservices e-commerce app. You got your checkout pod, needs to talk to the payment service. Now, the payment service might be running 1 pod today, 5 pods tomorrow during a sale, and those pods might get restarted or moved at any time. The checkout pod doesn't care. It's using an IP like 10.42.599. It just sends its request to the stable DNS name, payment.default.svc.cluster.local. Kubernetes DNS resolves that name to the payment service's stable virtual IP, the cluster IP. Then, the Kubernetes networking layer, using that service definition, routes the request to one of the currently healthy payment pods. So even if the payment service scales up, scales down, or pods get replaced, the checkout pod keeps talking to payment.default.svc.cluster.local, and the communication just works. It always finds the live instance.
All right, so we get the what and the why. This constantly shifting city of apps keeps its mail delivered reliably thanks to the system. But the how? That's where the clever bits are. How do service discovery and DNS actually work together? What's the mechanism behind this smart address book?
So the magic really happens through the interplay of 2 main Kubernetes components, services and the built-in DNS service, which, yes, typically CoreDNS. Services are Kubernetes objects that provide stable network endpoints, think stable IPs and ports, often for a group of pods, and they usually handle load balancing. CoreDNS is the component responsible for translating the names we use, like service names, into those stable IPs.
Okay, so walk me through the flow. What happens step by step when one pod wants to talk to another via service?
Sure. First, you, the developer or operator, create a service. You define a Kubernetes service object. In that definition, you specify a selector like a payment, which tells the service which pods it should target. Kubernetes then automatically assigns this service a stable virtual IP address called the cluster IP, and it also creates a corresponding DNS record for it. So if you name your service payment, it gets a DNS name like payment.default.svc.cluster.local, assuming it's in the default namespace.
Okay, service created, it has an IP and a name. Step 2.
Step 2 is DNS resolution. Remember CoreDNS running inside the cluster. When your checkout pod wants to talk to the payment service, its first step is to ask CoreDNS, hey, what's the IP address for payment.default.svc.cluster.local? CoreDNS looks up its records, finds the entry for the payment service, and replies with the stable cluster IP assigned in step 1. Let's say it's 10.96.0.10.
Got it. So the pod now knows the cluster IP. What next?
Step 3, pod to service communication. The checkout pod now sends its network request, like an HTTP request, directly to that cluster IP, 10.96.0.10. Now, the service isn't actually a pod itself. It's more like a virtual concept managed by Kubernetes networking, specifically often kubeproxy on each node. When traffic hits that cluster IP, Kubernetes intercepts it. It looks at the service definition, sees which pods currently match the payment selector and are healthy, and then it forwards the request to one of those actual back-end pods, effectively load balancing the traffic.
So the service cluster IP is like a stable front door, and Kubernetes networking plays the role of the receptionist, directing traffic to the right room or pod behind that door.
That's a great way to put it. And step 4, which is sort of ongoing, is dynamic updates. As those payment pods get created, deleted, become unhealthy, or get rescheduled, Kubernetes automatically updates the list of valid endpoints for the payment service. And Core DNS keeps its records pointing payment.default.svc.cluster.local to that same stable cluster IP. The key is the cluster IP and the DNS name don't change, even when the backend pods do. That's the stability.
Okay, that flow makes sense. Now, you mentioned earlier that sometimes you can talk directly pod to pod using DNS, like with that bot pod.cluster.local thing. Why would you do that, and why is it usually discouraged?
Right, good question. So normally you want to go through the service for the load balancing and resilience it provides. If one pod behind a service dies, the service just sends traffic to the others. But sometimes, particularly with stateful sets, think databases or other stateful applications, where each instance might have a unique identity and data, you need to address a specific pod instance reliably.
Like DB replica 0 versus DB replica 1.
It's exactly. For a stateful set named DB, with a governing service named DB service, Kubernetes can create specific DNS records for each pod, like dbo0.db-in service.default.svc.cluster.local and db1.db-service.default.svc.cluster.local. These records resolve directly to the individual pod's IP address at that moment. This allows, say, db0 to talk directly to db1 for replication or coordination.
But you bypass the service's load balancing and health checks then.
Precisely. That's why it's generally discouraged for regular stateless applications. If you talk directly to a pod IP via its DNS name and that pod dies, your connection breaks. The service provides that layer of abstraction and resilience. But for specific stateful use cases, direct pod addressing is essential.
Okay, that distinction is helpful. So just to crystallize this for everyone listening, let's quickly recap the absolute key components and what they do.
Sure. You've got the service, that's the Kubernetes object, giving you the stable IP, cluster IP, and the DNS name for a group of pods. It handles the load balancing part or enables stable discovery. And there's Core DNS, the built-in DNS server inside Kubernetes, doing the actual work of resolving those service and pod names to IP addresses. The cluster IP, that stable virtual IP address assigned to the service, used for internal communication within the cluster. Traffic to this IP gets routed to the backing pods, and occasionally the headless service, a special kind of service that doesn't get a cluster IP. Instead, querying its DNS name returns the IPs of all the individual pods it selects, used often with stateful sets for that direct pod discovery we just talked about.
Perfect. That really lays it all out. So the big takeaway, the core idea for anyone trying to get their head around this is that service discovery and DNS in Kubernetes genuinely act like a smart, constantly self-updating address book for your applications. DNS gives things easy names, so apps don't have to deal with messy, changing IPs.
Exactly. And the service discovery mechanisms using those names in the service objects make sure communications is reliable, simple, automatic, just robust, even while the underlying cluster is churning away.
What an incredible deep dive. We've really unpacked how Kubernetes manages to keep all these moving parts talking to each other, making that chaotic, dynamic city feel orderly, all thanks to that clever phone book concept.
It really does showcase how these sort of foundational pieces provide the stability and automation needed. They really transform how we approach building and managing these complex distributed systems, making the complexity manageable. Makes that dynamic city not just possible, but actually quite elegant to operate in.
Yeah, elegant is a good word for it. We really hope this deep dive has given you, our listener, a clear, solid understanding of how applications actually find each other in the world of Kubernetes. It's such a fundamental piece of the puzzle if you want to master modern cloud-native development.
Absolutely. So maybe a final thought to leave you with. Next time you're designing or thinking about an application, consider how much simpler this architecture makes things. Knowing that finding other components isn't some manual chore you have to script or configure, but it's just a built-in, automatically handled service. What new kinds of truly dynamic, truly resilient systems does that freedom open up? Things maybe we couldn't even realistically build before.